All right, what's up, guys? So recently we've been doing a lot of finding roots from functions, and today we're going to be kind of working backwards. We're going to be writing polynomial equations in standard form given the roots of a function. So let's go ahead and let's practice a little bit. So right in number one and number two here, we're given the roots, and we need to write the polynomial equation that goes along with them. So if we remember roots and what they mean, right, we get them from the factors of the function, right? So if we have a root of 3, we get that from the factor x minus 3. Because remember, we would set this factor equal to 0, right? X minus 3 equals 0. And we'd solve for x, we would get 3. Right? And the same thing goes for this negative 4 here. We would get this from x plus 4. Because again, we set that factor equal to 0 and solve for x, and that gives us the root. All right, so now that we have the factors, all we have to do is FOIL this out, and we'll get our completed function. All right, so we would do the first is x squared, and that would be minus 3x. Right, plus 4x, and then minus 12. Right, and let me do this. We can clean this up a little bit. And we would say f of x is equal to x squared plus x minus 12. All right, so not too bad. Now, here we have a root of 0, of negative 2/3, and 5. All right, so let's think about this. If we have a root of 0, what does that mean? Well, if you remember, anytime we have a root of 0, that just comes from the variable x being all on its own, right? Because we would set x being the factor equal to 0. All right, now we got to think, okay, how do we get a negative 2/3? Well, if we kind of think about how we find the roots given the factor, we can kind of work backwards from that, right? Because this is saying the root is when x is equal to negative 2/3. And what I want to do is solve this equation so that I'll have a 0 on one side, right? So I can multiply both sides by 3, and I get 3x is equal to negative 2, right? Then I can add 2 on both sides. So this becomes 3x plus 2 equals 0. And what I just did is I found my second factor. Right? It's 3x plus 2. And if you want to, you can do the same thing with this 5, right? I can say x equals 5. I can subtract 5, get x minus 5 equals 0, right? And I get my other factor now, x minus 5. All right, and from here, all I have to do is put all of this together, right? So we can start by foiling these two terms, these two factors. So we'll keep the x on the outside for now. All right, we get 3x squared plus 2x minus 15x, because it's negative 5 times 3x, and then minus 10. Right, and we can combine like terms a little bit. We get x times 3x squared. We get minus 13x minus 10. Then all we have to do is distribute this x into the problem. So we get f of x is equal to 3x cubed minus 13x squared minus 10x. Awesome. All right, let's keep going. So let's talk about a conjugate. A conjugate is where the sign changes between two terms. So we're going to be seeing conjugates, and usually when it comes to irrational and imaginary numbers. All right, so for instance, the conjugate of a plus the square root of b is a minus the square root of b. And the conjugate of a plus b times imaginary number is a minus b times imaginary number. All right, so we have this irrational roots theorem, and the wording is a little confusing, but essentially the summary is when we have one irrational root, its conjugate will also be a root. All right, so for example, number 3 here, we're given that the function is a degree of 3, but it only gives us 2 roots. All right, but given the irrational roots theorem, we know, okay, if negative square root 3 is a root, then positive square root of 3 is also a root. All right, so then all we have to do is we have to write these roots in their factor form, right? So we get so we get this root of negative 2 from x plus 2. We get this negative root 3 from x, we can say minus negative square root 3. And then we get this positive root 3 from x minus square root 3. All right, so we can clean this up a little bit. We can say this is x plus 2, x plus root 3, x minus root 3. All right, and then from here, all we have to do is FOIL this out. And let's start with the one with the irrational numbers, because it cleans up a lot nicer than what you think it will, right? So x plus 2, we're going to leave that the same. We're going to FOIL, so we get x squared, right? Then we get plus square root 3x, and then minus root 3x. And that's going to be positive root 3 times negative root 3 is going to give us a minus 3. Because remember, if we just multiply two irrational numbers together, right, they're both square root 3, right? So this is really like saying square root 3 squared, which is just 3. So now that we have this written out, we can see, okay, this is positive square root 3x minus square root 3x. That's just going to cancel. And then we just end up getting x plus 2 times x squared minus 3. And again, all we have to do is FOIL that out, right? So x times x squared gives us x cubed. 2 times x squared gives us 2x squared. Negative 3 times x is minus 3x. And then 2 times negative 3 gives us negative 6, which is our final function. Awesome. Let's keep going. Last problem, number 4. So the complex conjugate root theorem. It's really similar to the theorem we just looked at. What it's essentially saying is if we have one root of an imaginary number, right, then we also have its conjugate. So if we have a plus b times I, we also have a minus b times I. All right, so number 4, we're given that the function is a degree of 3, and it's got roots of negative 6 and 3 plus 2 times I. So we know it also has 3 minus 2 times I. So we just have to write that out, right? Our function then, from here, from this negative 6, we know it's going to have a factor of x plus 6. And then this is where it gets a little different, right? So we're going to have a factor of x minus this whole entire root here. So 3 plus 2 times I. And then we're also going to have one for its conjugate, right? X minus 3 minus 2 times I. Right? So we can kind of clean this up a little bit so there's not as many parentheses. We have x plus 6 times x minus, and we got to remember to distribute this minus into the problem, right? We have x minus 3 minus 2 times I. And then same with this, right? We're distributing this minus. We have x minus 3 plus 2 times I. Okay, so we have to FOIL this out, right? We have to kind of combine this all together. And one great way of doing that, if we wanted to multiply these two factors together, we could just use our box method. All right, so we would write out the terms. We can say like x is going to be on top. We're also going to have negative 3. So we're going to do this one on top. And then minus 2i. On the sides, we're going to have x. We're going to have negative 3. And we're going to have positive 2i. And then we can just finish up our box here. All right, so we know using the box method, we just have to multiply all of the terms on the side with all of the terms on the top. All right, so x times x, we get x squared. Negative 3 times x is negative 3x. And then 2i times x will give us 2ix. X times negative 3 is negative 3x. Negative 3 times negative 3 is positive 9. Positive 2 times I times negative 3 is negative 6i. All right, so x times negative 2i is negative 2ix. Negative 3 times negative 2i is positive 6i. And then positive 2i times negative 2i is going to give us negative 4i squared. Okay, awesome, right? So now all we have to do is add up all of the numbers here, right? So we know we didn't do anything with the x plus 6 yet, right? So we didn't do anything with the x plus 6 yet. So all we have to do is add up all of the terms inside here. So x squared is on its own. Negative 3x plus negative 3x, well, that's going to give us negative 6x. All right, then we have this 2 times I times x. But look, if we look here, we also have negative 2 times I times x, right? Those are our like terms, and they're actually just going to cancel each other out. So we have this positive 9, so we'll say plus 9. And then this negative 6i and positive 6i, they're also going to cancel each other out, which leaves us with just negative 4 times I squared. But if we remember, I is the square root of negative 1, right? So this is really like saying negative 4 times the square root of negative 1 squared, which is really negative 4 times negative 1, so we get positive 4. So clean this up a little bit, right? We can just combine these last two terms. We get x plus 6, x squared minus 6x plus 13. And then all we have to do is FOIL this out, right? We have to multiply everything in here by everything over here. And we can use the box method again, or we can just kind of distribute, right? We know we would have to do x times x squared, we would get x cubed. X times negative x, or sorry, x times negative 6x is negative 6x squared. X times 13 will give us positive 13x. 6 times x squared is positive 6x squared. 6 times negative 6x is going to be negative 36x. And then 6 times 13 will give us positive 78. Right? Now that we have this all written out, all we have to do are combine like terms. So x cubed, it's on its own. This negative 6x squared is going to cancel out with this positive 6x squared. Right? Then we have plus 13x minus 36x is going to give us minus 23x. And then plus 78. And we have our final function. All right, so if you guys have any questions at all, make sure you reach out.